Our focus today is on subtracting integers. And basically, we're just going to turn it into addition of integers, the piece that we were doing before. And so, verbally, to address this goal of subtracting integers, we'll note that if you want to subtract, it's nothing more than adding its opposite. For instance, 3 subtract a positive 7 is 3 plus its opposite, negative 7. And at this point, we've got some skill with addition of integers. So what's 3 plus negative 7? That's negative 4. In terms of algebraic notation with variables, A subtract B is equivalent with A plus the opposite of B. Please remember that when we have a negative sign in front of a variable, we don't read it as negative B. It's read opposite of B. Okay, so let's continue. 5 subtract 9. What's the opposite of 9? Okay, so we have got negative 9. And then we've got addition. 5 plus negative 9 equals a total of negative 4. All right, so the question was just asked, are we always just going to take the opposite of just the second number? Yes. The first number does not change whatsoever. The second number, we will add the opposite of the second one. So for this next problem, we'll notice then negative 4 stays the same, negative 4. First number won't change. That subtraction gets changed to addition. And in order to make that change, we have to take the opposite. The opposite of negative 10 is positive 10. And thus we're noting, just cleaning this up a little bit, negative 4 subtract negative 10 is equivalent with negative 4 plus positive 10. So what is negative 4 plus positive 10? 6. Different signs makes us subtract. We've got our answer and we're done. Okay, so continuing with the same piece. We know that we're doing this subtraction. We know that it's going to follow a pattern of the first number stays the same. Subtraction gets changed. And then we will change the second one to its opposite. So we're looking at same, change, and opposite. 3 will stay the same. Subtraction gets changed to addition. And then we have the opposite of positive 8, which equals negative 8. Now to rehash our addition rules, at this stage, we know that we're looking at the signs. A positive 3 paired with a negative 8. Because those are opposite signs, they're different signs, we have to subtract the numbers. 8 subtract 3 gives us 5. And because 8 was bigger than 3, we will keep the sign of the 8. That was negative, so we have negative 5, and we've got our answer. Okay, looking at the second one, negative 2 subtract 9. We know we have same, change to add the opposite, which is then negative 9. Adding our numbers together, we'll pay attention to the signs of a negative plus a negative. Those signs are the same. So our addition rule tells us that when the signs are the same, we add the numbers and keep the sign of the bigger one. For number 3, we have same, add the opposite. 6 plus positive 3 9, and we're done. All right. Our next example combines this skill with working with variables. In particular, we've seen before how to substitute in for evaluation. This is no different. When we are told an x value is equal to -8, we can start with doing a piece of substitution. After that substitution is done, it's the exact same thing as what we did before. First number stays the same. Take the opposite of the second. Adding together that -8 and 22, since the signs are different, we know we have to subtract. And because 22 is bigger than 8, we'll keep its sign. We get positive 14. Same will apply if the variable is on the right part. 9 subtract x would become 9 subtract a -8. So to subtract a -8, we have to add its opposite. We have to add positive 8. So what's 9 added to 8? 17, and we're done. All right, making our substitution, please note the directions. Evaluate when y is equal to -12. Well, just in the interest of saving time, I'm going to do the substitution on all three of them right away. Y, subtract 6. 19, subtract y. -7, subtract y. And now we'll do our subtraction. -12 subtract 6. We know that we have to add the opposite. Same, change, opposite. Following through. Same, change, opposite. Same, change, opposite. And so the question was raised, are we going to use this same change opposite rule for every single one? Yeah, that's what subtraction is. That's the rule on how you do subtraction of integers. So you add the opposite of the second one. And now that all three of them are turned into addition problems, we'll use our skills adding integers that we had before. 12 plus a -6, I'm sorry, -12 plus -6. Because it's a negative added to a negative, we add them and keep the sign of the bigger one. Going to this problem number 5, we have +19 plus +12. Signs are the same, so we add them and keep the sign of the bigger one. -7 plus +12. Signs are different, which tells us to subtract. 12 subtract 7 is 5, and keep the sign of the bigger one. Thus, we're finished. All right, now how does this subtraction get used? Well, subtraction is used in distance. Subtraction gets used in temperature. Basically, anytime that you want to have a measurement of change, how much did it change from beginning to end, that's always subtraction. And so here's an example where if we want to get the change in this problem, it's temperature, but it applies for change in anything. Change is always the ending, subtract the beginning. We're doing temperature, but it applies to distance, it applies to time, it applies to money, it applies to basically everything. So let's create a verbal model. What is the change in temperature to go from -5 degrees to +12 degrees? Well, which is the beginning and which is the ending temperature? 12 is the ending temperature because of the 2. -5 is the starting or beginning temperature because of the word from. Substituting those in, 12 subtract -5. And so if we want to subtract the -5, we have to add its opposite, +5. So we have 12 plus 5. Those add up to 17. And so when we look at this, we know that the temperature rose, or the temperature increased, by 17 degrees Fahrenheit. And we know that the temperature increased because we have a positive 17. If we had a negative, it would have told us that the temperature went down or decreased. I'd also like to note, make sure you take a quick look at the comment on the left. This process of change, ending, and starting does not apply only to temperature. It's elevation, it's time, it's money, it's everything. From beginning to end, it will always work with subtraction. Okay, so let's do the 2 last pieces here. What is the change in temperature from -3 to +8? We know it's going to be the ending value minus the starting value. So we know it's 8 subtract -3. Same, change, and opposite. 8 plus +3 equals 11. Thus, the change is it rose 11 degrees Fahrenheit. Continuing for problem number 8. We would have the ending value subtracting the beginning value. And so we can take -12 plus +15.
You said 12 for 2.
I said 12.
Yeah.
Thank you for correcting me, Chance. -2 plus +15 will equal 13. And so, since it's a positive number, once again, we know that the temperature rose, or it increased, 13 degrees Fahrenheit. Not Fahrenheit. That one's Celsius. 13 degrees Celsius.